welcome to our next lesson, 3-6 absolute value equations. Go ahead and put your name, that top right hand corner, and today's date. And now, I know some of you might be wondering, how come we're back to equations? I thought we were in inequalities. We are, but this absolute value section is actually one thing that I break apart into two parts. So this first part of 3-6, we'll just see absolute value equations, then we'll see 3-6 part 2, which will be our inequalities. So not to worry, inequalities haven't gone away. We're just going to briefly look at equations today. So our two objectives are that I can solve absolute value equations, and I can solve absolute value, well, it should be equations, forgot a word there, for different types of solutions. There we go. And now, if you notice, I have a line here. We'll come and use it here in just a second. But we're going to take our first two definitions here. So absolute value, I know something we've seen before, but just to remind ourselves, absolute value is a number's distance from 0. So if you think about absolute value being a number's distance from 0, if you think back to the absolute value of 5. Well, if we have 0 here in the center of our number line and we have so many tick marks in every direction, well, what is 5 away from 0? Well, 5 is. So, from 0, you go 1, 2, 3, 4, 5. So right there is 5. So 5 is 5 away from 0. But if you think about a number line, it goes two ways. It goes to the right, but it also goes to the left. So what else is 5 away from 0? That would be our negative 5. So the absolute value of negative 5 is also 5. Because we can go left 1, 2, 3, 4, 5. To negative 5. So negative 5 is 5 units away from 0. And positive 5 is also 5 units away from 0. If you think about the word distance here, distance is always positive. Because if you think about if you get in your car and you drive in reverse for a little bit, you don't say, oh, well, I went a negative amount of distance. No, you always count it as positive. So distance is always positive, which means absolute value is always positive. Okay. Now for absolute value equations, oh, that jumped on us. Try to get that back there. There we go. So distance is always positive, which means our absolute values are always positive. Put that back where it goes. Now, absolute value equations. Look at that from a different perspective now. So, absolute value equations are equations that have two possible solutions. And the reason why that is because if you think about the number line goes two directions. It goes right and left. So our equations have two possible solutions because we can get one that would be, for an example, to be to the right of that value, and we can also get one that would be to the left of 0 for that value. So that's why we end up with 2. Now, I do have an extra little spot here. If you want to make a star, there's a couple of things we just need to know about our absolute value equations. Because absolute value is positive, so because I'm going to put abs value, I don't have to write as much, so absolute value must equal a positive. Absolute value equations must me too. There we go. Put it back where it goes. Oh, there you go. Now, as far as that goes, as long as we remember like absolute values and number systems from 0, which means you end up with 2 cases, one that goes to the right and one that goes to the left, we're all set. Now let's see some steps.
Equations. So our first step is make sure the absolute value bars are alone on the left. Okay? Make sure the absolute value bars are alone on the left of your inequality. 2. Cannot, not, be equal or less than a negative number. Now, if it is equal to a negative number, it's automatically a no solution because absolute value cannot be equal or less than a negative. Step 3, we set up 2 cases because like we said before, we have one that's positive, one that's negative. So for our first case, the only change to the left side is losing the absolute value bars. That's the only change we ever make to that left side. So the left side of your inequality, the only thing we do is just drop away our absolute value bars. Alright, then for our first case, we set it equal to a positive number. And here's just one quick reminder before I talk about case 2. We lost our absolute value bars, so we don't have absolute value bars anymore. It's just looks like an inequality now. So on case 2, we set it equal to a negative number because it's now outside the absolute value bars. And I'll show that here in a second in the examples. So step 1 equals a positive, second case equals a negative. Alright, step 4, solve each case, and step 5, check. So these are our 5 steps for solving absolute value equations. Step 1, make sure the bars are alone on the left side. Step 2, make sure it doesn't equal a negative. Step 3, set up 2 cases. We lose our absolute value bars on the left, and we set it equal to a positive number. And for our second case, we set it equal to a negative number. Step 4, we're going to solve each case separately. Step 5, check. So here's our first example. We're going to go through our steps and say step 1, make sure it's alone on the left side. So we're just going to look to this side and say the absolute value bars are the only thing over there, so we're good. The absolute value bars are alone on the left. Step 2, cannot equal a negative. Do we equal a negative? No, equal a positive, so we're still good. Step 3, set up 2 cases. So all we're going to do is lose our absolute value bars on the left, which means we're going to say the absolute value of a minus 4 is a minus 4. And our first case equals a positive 3. We don't change it at all. For our second case, we lose our absolute value bars on the left and say a minus 4 is equal to, except this time I change my positive 3 to a negative 3. So I have my 2 cases, one that equals a positive number, one that equals a negative. Now step 4, we solve each case separately. So I'm just going to look at the first case here. So to solve my first case, I'm going to have to transpose my minus 4, make him a plus 4. So he disappears. I now have a alone on the left, and 3 plus 4 is 7. Okay, and basically when we solve the first case, the same exact steps we're going to have to use for the second case, except it'll be a negative 3 I have to add. So negative 4 comes and gets transposed to the right and becomes a plus 4. Disappears from the left, and we get a is equal to negative 3 plus 4 is positive 1. So now we have our 2 answers for what a could possibly be, and now we need to check it. So in our check, we're going to have to check both solutions to make sure that both cases work. So we always go back up to the original before we messed with it. A minus 4 equal, so absolute values bar, so a minus 4 equals 3. So now we're going to say the absolute value of a is now 7. 7 minus 4 is 3. And the absolute value of 7 minus 4 is 3. So the absolute value of 3, we say the absolute value of 3 is 3, and 3 equals 3, so we check. Now we do the same thing over here. We always go back to the original before we mess with it. A minus 4 equals 3. Except this time I replace a with 1. So the absolute value of 1 minus 4 equals 3. Now we say 1 minus 4 is negative 3, so the absolute value of negative 3 equals 3. And the absolute value of negative 3 is 3. So once again, we're good. We check. Okay, and since both of our solutions check, that means both of these are answers to this absolute value equation. Absolute value equations will always have two cases. So let's look at our second example. So step 1, make sure the absolute value bars are alone on the left side of your equal sign. So looking to the left side, they're all by themselves. Now step 2, make sure it equals a positive. So equal positive, we're good. Step 3, set up two cases. So we're going to lose our absolute value bars and say the absolute value of 2x minus 6 is 2x minus 6. Our first case we set equal to the positive 4. So positive 4. So if you look, basically nothing on the first case changes. All we do is just lose our absolute value bars. Then for our second case, we have the absolute value of 2x minus 6 is 2x minus 6 equals, except on case 2, instead of equaling a positive 4, it's going to equal a negative 4. So now we just solve each case separately. So solve for x, and we have to take my minus 6 and make him a plus 6. So he disappears from the left. I get 2x equals 4 plus 6 is 10. Now to solve for x, we're going to divide both sides by 2. 2's cancel. X equals 5. Alright, so on case 2 we do the same thing. We're going to transpose our minus 6 and make him a plus 6. So he disappears from the left. I get 2x equals negative 4 plus 6 is positive 2. Last step to solve for x is divide both sides by 2. 2's cancel. X equals 1. Once again, for the check, because this is an equation, so we go back up to the original. Alright, we say the absolute value of 2x minus 6 equals 4. Except this time I replace x with 5. So 2 times x is now going to say 2 times 5 minus 6 equals 4. So 2 times 5 is 10 minus 6 equals 4. So the absolute value now of 10 minus 6 is 4. And the absolute value of 4 is positive 4, and 4 equals 4. So we check. You do the same thing over here. We go back to our original before we messed with it. And when we substitute x in for 1, so 1 in for x, I'm sorry. So 2 times x is now 1 minus 6 equals 4. So the absolute value of 2 times 1 is 2 minus 6 equals 4. 2 minus 6 is a negative 4, so the absolute value of negative 4 equals 4. Absolute value of negative 4 is positive 4. Remember, absolute value can never be negative, so the absolute value of negative 4 is positive 4, and we check. So once again, these are both our answers. We have x equals 5 and x equals 1 as our solutions. Alright, example 3. We have 5x plus 7. Sorry, the absolute value of 5x plus 7, and then outside the absolute value bars is plus 10 equals 3. So step 1 is to make sure the absolute value bars are alone on the left side. So if I look to the left side of my equal sign, I have a 10 over here with my absolute value bars. So I have to transpose my plus 10 and make him a minus 10. and it disappears from the left. I get the absolute value of 5x plus 7 equals 3 minus 10 is negative 7. Now step 2 says it cannot equal a negative. So we look, and I have that the absolute value bar is equal to negative 7. So that can't happen, so it's automatically a no solution. So anytime by step 2 you have your absolute value bars alone on the left side and you equal a negative number, it's automatically a no solution. So that finishes up for solving absolute value equations. Thank you very much.
All right, one last example here, example 4. We're given 7, and then the absolute value bar is negative 3 plus 7n equals 70. Alright. So we have 7, and because our side by sides being multiplied, so 7 times the absolute value of negative 3 plus 7n equals 70. Alright, step 1 is to make sure the absolute value bars are alone. So as far as it goes, they're not alone. I have a 7 outside there. So if they're side by side, that means they're being multiplied. So to get rid of my 7 times in my absolute value bars, I have to divide both sides from 7 from the get-go. So divide both sides by 7. 7's cancel. We end up with the absolute value of negative 3 plus 7n equals, now 70 divided by 7 is 10. This time, because we now equal a positive number, we're good to go, so we can keep solving. So we're going to set up our two cases. Our first case will just be our negative 3 plus 7n equals positive 10. And now our second one will always be the same thing that's inside the absolute value bar, so negative 3 plus 7n. We never change what's inside those absolute value bars, we just drop it down, equals, and this time we're going to be negative 10. And guys, this is our last example. I'm just going to remind you, at this step, there are no absolute value bars when you make your two cases. That's extremely important. And that's because, if you remember, we said that the absolute value bars cannot equal a negative, so it doesn't, it equals a positive. When you set up your two cases, you don't have to worry about that anymore because there are no absolute value bars on there. So that's how you can say, like, this is 10 away from 0, and that one's also 10 away from 0, is negative 10. Now at this step, you just, you just solve for n. So we're going to transpose our negative 3 and make him a plus, so 7n equals 10 plus 3. 10 plus 3 will give me 13, and divide both sides by 7. 13 over 7 doesn't reduce, so we just leave that as a fraction, so n equals 13 over 7. Alright, and now the second one has the exact same steps. Transpose our negative 3, we'll make him a plus 3. Negative 10 plus 3 gives me negative 7, so 7n equals negative 7. Divide both sides by 7, and n equals negative 1. So as far as that goes, that finishes up our notes. If you did want to do a formal check, remember you just plug in your answer up there, or we'll real quick do like a little bit of mental math and say 7 times 13 sevenths gives us 13. Negative 3 plus 13 is 10. The absolute value of 10 is 10. 10 times 7 is 70, so that works. Go through their mental math real quick with your negative 1. 7 times negative 1 is negative 7. Negative 7 plus negative 3 is negative 10. The absolute value of negative 10 is positive 10. 10 times 7 is 70. So you can always go back through there, double check your answers. But with that, we're all set. Thank you so much.